Hello, AP Physics brethren. My name is Clayton James Canal, perennial basketball superstar. Before we get started, I want to give you a little demonstration of my skills.
First, let's explain the basic principles of shooting a basketball with rotation.
When you're shooting the ball flat-footed without bending your knees, all the force comes from your upper body.
As far as putting rotation on the ball, this is due to torque being equal to force times lever arm, with the lever arm being your wrist and the force being the force of friction due to your hand touching the ball. This torque introduces rotational dynamics. This introduction of rotational dynamics alters the velocity of the ball. If the ball is shot with no rotation, its kinetic energy will be equal to 1/2 mv squared. However, with rotation being added, the kinetic energy is now equal to 5/6 times mv squared. Assuming the kinetic energy and mass remain the same, 5/6 is greater than 1/2, meaning the v squared with rotation must proportionally be lower. From this knowledge, we wanted to determine the best jump shot technique when rotating the ball, according to physics. We decided the best shot would be the one that requires the least force from your upper body and still goes in. We pitted the most common shooting technique, shooting at the apex of your jump, against 3 alternative ones. Scenario 1 being a set shot without bending your knees. Scenario 2 being shooting on the way up, before the apex of your jump. Scenario 3, shooting on the way down, after the apex of your jump. And Scenario 4, shooting at the apex. In all 4 scenarios, the Magnus effect, the Coriolis effect, and air resistance are all negligible. Also, the force in the x direction remains the same. In the 3 scenarios in which jumping is involved, the jump takes the same amount of time and reaches the same max height in the y direction. We asked some physics students for their thoughts. Feel free to pause the video after each question and formulate your own hypothesis.
Scenario 3 versus 4. In which situation, scenario 3, does a hand exert more force on the ball for it to get to the hoop? Is it scenario 3, which is when you're shooting on the way down, or is it scenario 4 when you're shooting at the apex?
Scenario 3, because it's harder to shoot on the way down than it is at the top of your shot.
Scenario 4 at the apex of the leap.
Scenario 3, on the way down.
In scenario 3, the jumper is moving down in the second half of his jump. The ball is moving down with the shooter. This gives the ball a negative downward momentum. As a result, the shooter must apply a greater force to the ball to overcome the negative momentum the ball has since it is moving downward. This is compared to scenario 4, when the shooter releases at the apex. With no velocity at the apex, there is no momentum transferred to the ball. As a result, the force the shooter exerts on the ball is the same as if there was no jump at all, like flat-footed shot. Next question, scenario 1 versus 4, which is a flat-footed shot versus the apex. In which situation does the hand exert more force on the ball in order for it to reach the hoop?
Flat-footed shot because there's no assistance from a leap.
I'd say flat-footed shot as well.
I concur with these 2 gentlemen.
In scenario 1, the shooter has chosen not to bend his knees. As a result, all the force comes from the shooter's upper body. In order to travel in a parabola, there are force components in the x and y direction. In scenario 4, this shooter did jump. You may think that there is positive momentum on the ball because of the jump up. However, this is not the case. Since the shooter has reached the apex, he is moving neither up nor down. His velocity in the y direction is 0. As a result, there is no momentum transferred to the ball when it is shot. So, the force of the upper body, or the hands, must be the exact same as in scenario 1. Question 3. In which scenario does the hand exert more force on the ball for it to reach the hoop? Is it scenario 2, which is when you're shooting on the way up, or is it scenario 4, which is when you're shooting at the apex?
I'm going to say scenario 4 while you're shooting at the apex.
I'll have to agree due to the fact that there's assistance this time from the rest of the body on the jump, so the hands don't need to do as much work.
I think 4, shooting on the apex, requires more force because when you're shooting up, the momentum of your body creates more force on the way up than when you're at the top of your shot.
In scenario 2, the shooter releases the ball as he is jumping up in the air. The ball moves upward with the shooter. As a result, the ball has a positive momentum in the y direction. Since the ball is already moving up at the point of release, the shooter does not need to apply as much force to the ball as he would when he is not moving up or down, as in scenario 4. In scenario 4, the shooter is at a standstill in midair. There is no velocity, which leads to no momentum for the ball. Thus, in scenario 4, the shooter must apply more force to the ball than in scenario 2 with his upper body.